I said at the beginning of the last video that a University of Illinois study showed 20 instrument pilots lasted an average of 178 seconds in simulated IMC encounters. This 178 seconds to live is often quoted, and it might leave you hopeless for your prospects should you accidentally enter IMC. And while accidental IMC encounters very often do end badly, that statistic doesn't tell the whole story. The objective of that study was not to test inadvertent IMC encounters in typical conditions. Instead, it was to test whether non-instrument rated pilots could be taught a 180-degree turn maneuver in IMC. The 178 seconds result came from the control group, a group of pilots with 0 instrument time. Without any training, that group of pilots was put under the hood in an unfamiliar airplane, a Bonanza, chosen specifically because preliminary testing indicated the technique would be most difficult in it. The attitude indicator, directional gyro, and vertical speed indicators were covered to simulate the bare essentials for VFR flight. The plane was loaded to max gross weight with the maximum allowable aft center of gravity. It's no surprise these pilots struggled, or that given some training, they improved. The goal, of course, is to avoid inadvertent IMC encounters, but a private pilot should develop solid instrument skills so that if it happens, it doesn't end in disaster. Let's get ourselves into some accidental IMC encounters and try some of the techniques for getting out. The first step after accidentally entering IMC is to maintain straight and level. Breathe first, and then act. So what if we enter IMC and realize we're not straight and level? Then it's a recovery from some degree of unusual attitude. Easily the most likely scenario is a spiral dive. The turn develops unnoticed, it gradually gets steeper, the nose drops, and a descent starts. The pilot notices the descent and the increasing airspeed and pulls on the yoke. That just tightens the spiral and increases the G-load. If ground impact doesn't happen first, structural limits are exceeded and the airplane comes apart. Your newer Autopilot might have a level button. If it does, press it, unless you know for sure and in a heartbeat that you can do better. Other Autopilots might be able to recover from more minor upsets in a wing leveler mode, but read the manual and try it in controlled conditions. But the Autopilot is probably not aggressive enough to recover from severe upset attitudes. It might hit the limits of its control input, and it might just be unable to parse what's going on. So let's focus on unusual attitude recovery techniques first, and apply some basic steps for recovery. The method we're going to use is power push roll. It originated with Rich Stowell, and you can read more about it in his book Emergency Maneuver Training. Priorities here are avoiding overspeed and overstress, and then returning to level and under control. First, check airspeed. If it's high or increasing, reduce to idle. If it's low and decreasing, which is less likely, add full power. If there's any doubt, just go to idle. That reduces the amount of energy in play and the rate at which things can get away from you. Step 2 is to push to unload the wing. This might be counterintuitive for a nose-down unusual attitude, but avoiding overstressing the airframe is the other priority here. Pushing on the yoke for about 1 G will accomplish that. Basically, push until you feel normal. At the very least, don't pull. And this step will emphasize the need to level the wings, the next step, before applying any back pressure. So step 3 is level the wings. The turn coordinator is often the best reference here because it's not susceptible to tumbling like some older attitude indicators. And it allows you to focus exclusively on rolling the wings level at this step since it doesn't present pitch information at all. But it does lead the actual rollout slightly. That's because in addition to showing rate of turn coordinators are responsive to roll rate. You can see here that while the attitude indicator is correctly indicating wings level, the turn coordinator is showing a turn to the right. It's overshooting due to the fact that the airplane is actively rolling to the right. That's okay, just be prepared for this effect, and that you may need to make several adjustments to achieve level flight. On the other hand, if you have a PFD, it might have chevrons to follow back to straight and level flight. But just remember to level the wings before pitching. Level the wings first, and then follow the chevrons back to the horizon. Step 4 is to recover back to straight and level flight. In a high-speed spiral scenario, once the wings are leveled, the nose will want to pitch up dramatically on its own. Be prepared to actually have to push to stop it from over-pitching. So let's take a look at this in practice. Alright, so let's run through an unusual attitude recovery here. So this is the scenario. We've just entered the clouds. We're disoriented or distracted, and typically what happens is a small bank starts up. And pretty much all general aviation airplanes have some spiral instability, so this bank gradually increases, gets steeper, the nose starts to drop as that happens. We still haven't noticed anything yet. But here we start to hear the RPM increasing, hear the wind increasing, start to feel some G's building up. And now the recovery is, speed is high and increasing, so it's throttle to idle. Push, roll the wings level.
Sync rate.
And then pitch for the horizon. And now I'm just pitching for the horizon, just level flight on the attitude indicator. I don't care much what I'm getting from that. I'm going to add power back in until it feels like it's about at cruise power. And I'm just trying to get my bearings back here. Alright, there's something else I want to demonstrate here, so let's get into one more. So we'll set up for that same steep descending unusual attitude situation. Speed is building up. Now if all I do is go power idle and wings level here,
sync rate,
not applying any back pressure here at all, you can see how high the nose goes on its own. And so actually to get the nose back to the horizon in the recovery, it involves a push. But now if I don't do anything, so I'm not applying any forward or aft pressure on the elevator, we're going to oscillate back and forth here. And it's probably going to be disorienting and uncomfortable, but eventually, just by holding the wings level, the airplane will find itself back in equilibrium at whatever speed we were trimmed for before the upset occurred. So you can see this oscillation is a lot less than the first one. Now we're just going to about 5 degrees nose up. And let's add cruise power back in. So just by leveling the wings and doing nothing else, eventually the airplane should find itself back in straight and level flight. With some altitude loss, of course, so it's better if you can intervene, but at least it's good to realize that you can take advantage of the airplane's natural stability. It's easy to make this situation worse by over-controlling. That technique could be especially useful in the case where, say, the attitude indicator had failed or exceeded its limits and tumbled. Now all you have to do is look at the turn coordinator here and level the wings, and eventually you'll find yourself back in straight and level. Alright, so this time we've flown into the clouds and we haven't entered an unusual attitude yet. We've managed to keep it in straight and level flight, and we want to keep control of the airplane here. A lot of times your best solution is going to be the autopilot, but you want to know how it engages when you turn it on, what modes engage when you turn it on. So I'm just going to press the autopilot button here, and this autopilot engages in wings level, so it levels the wings, and whatever your current vertical speed is. So right now we're in vertical speed mode with 200 foot per minute of descent and wings level. And now things are under control. Now I can engage the autopilot modes that I want. So I probably want altitude mode, and just pressing the altitude button here switches from vertical speed to altitude mode at our current altitude. So now we're wings level and we're maintaining an altitude. So the next step here is going to be engaging heading mode, and when I do that, the autopilot's going to follow the heading bug. And you can see that I've got the heading bug on my current heading, which is a good habit to keep. And one reason that's a good habit is that you can engage heading mode and the airplane will stay right where you left it. So I press the heading button here, and now I'm in straight and level flight on this heading and at my current altitude. And now I can steer the airplane with the heading bug. So if I want to turn around, grab the heading bug and spin it around in the other direction, and the autopilot follows. So that was engaging the autopilot and getting it to do a simple 180-degree turn. Every autopilot works a little differently, so you'll want to practice this with yours. And the 180 turn might not always be the right call. Sometimes a climb or descent, or even just continuing straight ahead, might be the best choice. So spend some time with your autopilot and get proficient in engaging the autopilot and then doing turns, climbs, and descents with it. So what if you don't have an autopilot? Well, naturally you want to develop some solid instrument scan fundamentals, but here I want to focus on a few specific escape techniques with an emphasis on simplicity. If you've accidentally flown into the clouds and you're not instrument rated, you might be disoriented or overwhelmed, and you want the simplest and easiest ways to get the plane under control and back into visual conditions, and sometimes those techniques are overlooked in training. The standard textbook answer for what to do in a case like this is to make a 180-degree turn. That's not always the best answer, but let's run through that first. In instrument flying, you make standard rate turns, and you use the turn coordinator to set that up. I'll enter a standard rate turn here, and you can see that the wings on the airplane on the turn coordinator line up with the tick marks. That's a standard rate turn. And standard rate is a turn where the heading changes by 3 degrees per second. That's the rate at which pretty much all turns under IFR are made. What's useful about that is that we know if we turn at a rate of 3 degrees per second, a 180-degree turn is going to take 60 seconds, or 1 minute. So if I just make a standard rate turn and count off 60 seconds, I should be more or less turned around. My preference, though, would be to use the attitude indicator versus the turn coordinator, because the attitude indicator gives us pitch information too. We can imagine the attitude indicator as an out-the-window view and just set up the appropriate bank angle for a standard rate turn. What the bank angle is that results in a standard rate turn depends on true airspeed, and at 100 knots, it's about 15 degrees. But we really don't need to be that precise here. If you just make about a 15-degree bank turn for about a minute, you'll be going more or less the opposite direction, and that's the goal. So I'm going to make a 180-degree turn here using only the attitude indicator and some mental timing. I'm just going to count off the seconds. So I'm going to roll into about a 15-degree bank, right about here, and just start counting 1001, 1002, 1003, 1004. I don't care about being real precise. If I'm off by 10 seconds, I'm still going to be basically turned around. In 15 degrees of bank, the bank scale on the attitude indicator is at the top. So this first tick mark is 10 degrees, second is 20, I'm halfway between the two. That's a 15-degree bank turn, which should get us about standard rate. So I'm just holding the nose on the horizon for pitch. It should stay pretty much there without having to do anything. Maybe a slight bit of back pressure, but not much. I'm just holding this sight picture on the attitude indicator and counting off the seconds. I've been talking and not counting, but once we get to 60 seconds in our mental count off, we should be pretty close to turned around. You know, maybe it's here that we end up being about 20 degrees off of the reciprocal heading that we started on. That's totally fine. That should still get us heading basically in the opposite direction. And resist any temptation to look outside here. Don't trust what you might be feeling. You need to focus on the instruments here and trust them, and once the turn's complete, you can check if it was successful, but as long as you're in the clouds, keep your eyes on the panel. Of course, if you have a little more mental bandwidth available, or you've got a decent instrument scan, you should be able to bring in some other instruments too to tell you when you've got it turned around. Of course, the heading indicator is going to be useful for that, but even the GPS moving map might be a good way to gauge it, because it's a nice big picture that shows the direction that we're going. The downside is it's a little bit farther away from the center of the panel, so we'd actually have to look. But just making the turn, counting off about 60 seconds, then going back to straight and level flight and reevaluating whether you need to adjust again, is a pretty simple way to do it. We said that 180-degree turn is the textbook answer in these cases for what you should do, but there are plenty of situations where there's a better answer. And let's say in this case we just entered the clouds, we're at 4,000 feet. The ground elevation here is about 1,000 feet, and maybe we know we're right at the cloud bases, so a much simpler solution here would be just to start a little descent. So again, a single instrument solution here is focus on the attitude indicator and just focus on keeping the wings level. So we're keeping the triangles lined up at the top of the attitude indicator. And now I'm going to grab the throttle and just bring it back until I hear some perceptible sound change. Of course, if you have a constant speed propeller, you don't have the sound cue, but you can still bring it back by feel. Usually when people bring the throttle back about that much, they end up with 200 RPM or so of reduction, which gives a few hundred feet per minute of descent. All I'm doing is keeping the wings level here. I'm not doing anything with pitch. And the pitch dropped a little bit, the descent started. It'll oscillate up and down a little bit, but we get a nice descent, a nice slow descent. And just keeping it as simple as possible. Now if that doesn't get us out of the clouds, and we're getting lower than we want to be, to level off, we just do exactly the opposite of what we did. We undo the changes that we made. So I'm going to add power now until I hear a perceptible sound change. There it is, and now we're right back where we started. very minimal effort, and we're back in straight and level flight here. You might think that the best way to fly if you accidentally enter the clouds is using synthetic vision, because that gives you essentially an outside picture. You might think that's the closest thing to actually flying the airplane with your eyes outside. And that might be the case, but it depends a lot on your setup. So here I've got an iPad, and it's connected to an external AHRS source, like a Stratus receiver or something like that. So I have synthetic vision, and I can turn it on here. And actually, the fact that I have to enable it is one of the downsides of it. Because depending on how your iPad is configured, what screen you're on, you might have to change screens, you might have to activate it, and that's all work that you have to do that you might get disoriented while you're doing it, just to get to a screen where you can fly the airplane. You also might have your head down at an unusual angle. If your iPad's in your lap or on a yoke mount or something like that, that can be a recipe for disorientation too, just having your head down in the cockpit like that when you're in the clouds. On the other hand, if you have a glass cockpit with a PFD in front of you and fully integrated synthetic vision, that might be your best option because it's right in front of you, it's right where you'd be looking anyway, and you have an outside picture there. One good thing synthetic vision will do for you is show you whether or not there's an immediate risk of hitting something. So here, seeing that there's nothing in the way gives me the confidence to slow down, keep control of the airplane first, and then make and execute a plan to get back to visual conditions. I think the best thing that you can do for yourself is just make good decisions in the first place so you don't end up in these situations. Then also have some solid instrument scan fundamentals, practice these skills so that if you do, it doesn't end in disaster, and practice some simple techniques like enabling the autopilot and using that to help yourself get out.